Hello, welcome to the session of Instrumentation Engineering, and today the discussion topic is Introduction to Control Valve. Myself Somak Karan, Assistant Professor, Department of Applied Electronics and Instrumentation Engineering, Haldia Institute of Technology. The prerequisite to understand these particular topics are sensor and transducer, industrial instrumentation and control theory. So those have this particular idea about the industrial instrumentation, sensor and transducer and control theory. They are able to know this particular topic very easily. So before we proceed to the particular control valves discussion, we need to go through a very general block diagram which is known as general control loop block diagram. And from where we start the discussion of the control valve, that will be located over this particular block diagram. So we know that using this particular feedback control, we are able to control any one of the processes. And in that particular control logic, we have the blocks of controller, process, measurement, sensor transmitters, final control elements. So if we think about, we are in a room and we try to maintain the temperature using the AC. So in that particular time, in a hot summer time, the temperature is nearly 40 degrees centigrade atmospheric condition. And we want to make the room temperature 20 degrees centigrade. So in that particular case, what will be the action for this particular closed loop or feedback system? So whenever we start the machine or the air condition, the controller will try to understand that what is the temperature right now, and that will be done by the measurement or the transmitters. So basically the temperature sensor will measure the temperature, and obviously the initial temperature will be reflected as 40 degrees centigrade, and the set point which we have given as 20 degrees centigrade. We are required this particular temperature, the desired temperature in our room. So in that case, obviously the comparator block will compare the temperature, that the error will be generated, and obviously because there is a error difference, the 20 degree temperature difference is there, the controller will do the particular thing using the error, only the mathematical calculations, that how much actions or the controller output need to be generated. But we need to remind this particular point that the controller output needs to be taken care in terms of a voltage or current. But using this voltage or current, your room temperature cannot be decreased. So someone needs to take the responsibility that using the command from the controller or the controller output signal, that will be reflected that the temperature needs to be decreased in the room, and that will be done by the final control element. So our major discussion topic is nothing but the final control element. In the industry, the final control elements are taken care by the control valves. So this final control element, for the case of a AC, the compressor will be the final control element. So this final control element will take the responsibility, compressor will start, and accordingly the action for the compressor, we are getting the chilled air into the room, and after a few times we are able to reach this particular set point. So this final control element will be the topic of discussion today. And if you think about in a very general example, that for a football team there will be a coach. Coach will never go to the ground to play the matches. He will only give the instruction and the ideas and the planning that how the team will be executed into the football ground. So the controller will do the same thing. Controller will not execute particularly that what needs to be implemented by the final control element. Only the planning, the control actions will be generated by the controller, but the players, they are the final control element. They are executing particularly the plan or the ideas which is given by the coach. So that is the point of a final control element. Someone needs to take the responsibility to implement what actions will be given by the controller. So it is the main topic of discussion of the final control element. In industrial scenario, the control valve will be the final control element, which is the major topic of discussion today. So if we talk about the control valve, so the control action in any control loop is executed by the final control element. So as I already informed to you about the final control element, so the control action in the control loop system is executed by the final control element. And the most common type of final control element used in chemical and different types of industries, they are nothing but the control valves. So these particular things already we know about. And the control valve manipulates what they are manipulating in the industry. If we want to think about, they are manipulating the flowing of fluid such as gas, steam, or the water, or any chemical compounds to compensate for the load disturbance. That means if we are deviating from the set point value, so the load if given, so in that particular case again the control action needs to be generated, and the controller will give the responsibility to the final control element or control valve, and it will make again the same actions of the error compensation, and it will go to the point of set point. So it is the discussion of the final control element. And some control valves designs are intended for the on-off type. That means we know that the control valves can be used in two manners. One manner we can say that the control valve is on, in which all the liquids can flow through your pipeline, and the off, that means there will be no liquid flowing through your pipeline. But it is not only the single condition, you can go through the proportional value of the control valves. That means the 10% opening, 20% opening, 30%. So there will be a very high chance of controlling by the throttling, by the design to the throttle fluid somewhere between the full open and fully closed condition. The proportionally you can increase the values. And if you go through a point of the discussion which we have idea about the electrical circuit, so basically the electrical equivalent of an on-off valve that can be called as a switch. And while the electrical equivalent of the throttling valve is a variable resistance. So variable resistance means we can able to change the value of the resistances. And if we fix a particular resistors, the value will be that much. If you put it out, there will be no resistances. If you put it down, the same resistances you are getting. But if we talk about the proportional changing of the control valves opening, so in that cases you have a variable resistors. We are talking about this example of a variable resistors in which we are able to change the opening of the control valves. Here we are changing the value of the resistances. A control valve essentially consisting with two of the major parts, which is plug and the stem. So the motion of the plug and the stem will utilize to make the control valve open and close. And the stem can be raised or lowered. So basically the movement of the stem will be lower and the upper side raised or lowered by the air pressure. Obviously most of the cases the industrial control valves are used as a pneumatic control valve in which air pressure signal will be given to open and close it. And the plug changes the effective area of the orifice. So basically orifice idea we have in the industrial instrumentation. That means it is a constructive path through which the fluid can flow through it. That is also the point or the parts of a control valve in which a orifice area or the orifice we have made it. So this is the diagram of a peculiar control valves if we talk about. And the control valve is consisting with the diaphragm first. So diaphragm is taken care the air pressure which is given into the pneumatic control valve. It is mostly 3 to 15 psi of air pressure signal we have given. After that we have a spring arrangement to move the stem. So basically this particular structure is called as a stem, and the stem is located with the spring, and at the bottommost part of the stem we have a plug. And we talk about the orifice, so this area we can call it as a orifice. So the fluid will flow through from the upward direction or the upstream side, and it will go to the downstream direction through this particular area which is the orifice, and that will be going through the plug. It can go ups and downs, and it can restrict this particular orifice area to maintain the flow rate into the pipeline. So if we talk about the working principle, so our typical control valve action can be explained using the figure which we already discussed right now. And when the air pressure is increased, the downward force of the diaphragm moves stem down against the spring. So whenever you are giving some air pressure signal from the diaphragm, your stem will move, and according to the movement of the stem, your plug will try to restrict the path of the orifice. The bottom portion of the pneumatic valves has an orifice that separates the upstream and downstream flows. Already we have discussed this point. A tapered plug capable of blocking the orifice in varying proportions. As I already mentioned, in different proportion you can maintain the flow of the liquid 10% opening of the valves, 20% opening of the valves, or you can make it on and off type of valves as well. Attached to a stem that is connected to a diaphragm in the top portion of the valves. A spring, basically I just give you the idea about the spring which is located into the stem. The spring is restrict the movement of the stem. So whenever you are going down, whenever you are giving some pressure 3 to 15 psi in your diaphragm, your stem try to move downward direction. So opposite actions will be maintained by the spring, and when the air above the diaphragm forces the stem to move downwards, the plug starts reducing the aperture of the orifice. So when the plug will go down, so it will try to restrict the area of the orifice and eventually blocks the orifice at high pressure. As a result of the flow of the fluid through the orifice is gradually decreasing from full flow. When you are not giving any type of restriction, your plug will not try to restrict the path of the orifice. In that particular time, your liquid is total liquid can able to flow through the upstream to downstream side. But when it will try to restrict it with the full force of the air of the pneumatic signal and closing your orifice, in that time there will be no flow condition will happen. And as the air pressure at the top of the diaphragm is released, the plug moves back to its original position, resulting in full flow of the fluid. So whenever you are reducing the air pressure which you have applied 3 to 15 psi, so in that time again the reflect action will be given by the stem, and it will be advantageous by the spring arrangement, and it will go back to the same position. And this is called the two of the operating condition of the control valve. One is known as fail open type of valves, because when the control valve signal fails to provide the enough air pressure, the valve remains in fully closed condition. That means if you are not giving any type of air pressure signal 3 to 15 psi, if your plug will not restrict the entire orifice area, so in that particular time the total liquid can flow through it. So this particular type of control valves can be called as a fail open. So if you not able to provide any air pressure signal, in that particular time your control valve is totally open. And obviously another options we have which is fail closed. So that means in that particular time initially your plug will restrict the orifice area. Whenever you are giving the 3 to 15 psi signal, in that time your plug will go in a upward direction or downward direction and try to remove the restriction of the orifice, and you are able to flow the liquid from upstream side to the downstream side. So they are the very important point which we will discuss in the next slide: fail open and fail closed control valves. From this diagram also we are able to understand this particular thing of fail open and fail closed control valves. So you are able to visualize that both the diagrams is nothing but the similar type of diagrams. Only the change, if you try to observe, is the plug position. So here you are seeing that there is a plug position, or the orientation of the plug position is opposite. If you call about the fail open, so obviously initially when you are not giving any air pressure signal 3 to 15 psi, so in that time there will be no restriction at that particular orifice area. Your fluids can easily go through from the upstream to the downstream side. Whenever you are giving some pressure, so the plug will try to restrict the orifice. And because we have not given any type of signal at the initial, it is known as fail open. That means if you are unable to provide any 3 to 15 psi or the pneumatic signal, it is acted as a open control valves. Only by changing the orientation of the plug position or the plug orientation, so in that case initially what will be done, when you are not giving any pressure, the restriction will be given into the orifice area, and when you are giving some pressure, so it plug will gradually going down and try to give a path through which your liquid can pass through it. So this is called fail close. If you are unable to provide any air pressure signal in that particular time, the control valve will completely close. No liquid or no stream can flow through the upstream to the downstream side. If you go for the terminology of the control valve, so the control valve is mainly divided into the two parts. One part is known as the actuator part or the controlling part, and another part is nothing but the valve, or what is the nothing but the body and the trim. So the valve will be divided into the two segments. One is known as body and another segment is known as trim, and the actuator part is nothing but a pneumatic, hydraulic or electrical powered device that supplies force and motion to open or close the valves. And if we go for the definition of the body consists of a housing. So we need to maintain the particular control valve in a housing, that the different atmospheric condition not differing the operation of the control valves. So the body consisting of a housing for mounting the actuator and connection of the attachment of the valve to a supply line and the delivery line. Supply line means it is the upstream side of the pipeline, and the delivery line means it is the downstream side of your control valves. Packing is nothing but the same idea or the concept, that a part of the valve assembly used to seal. So basically you need to seal the control valves from the atmospheric condition against any leakage around the valve discs or stem. So there will be no leakage for the control valves if you try to maintain a perfect operation from it. Positioner is a important point of the discussion, which is nothing but a servo mechanism, we can say, and that is mechanically connected to the moving parts of the final control elements. So the final control elements, ups and downs movement and all the things can be controlled by the positioner, and its actuator, and that automatically adjusts its output to the actuator to maintain a desired proportion in proportion to the input signal. So whenever the input signal will be given, your positioner will try to give the instruction, and the actuator will try to the actuator will try to give the instruction, and the positioner will try to maintain the position. That means you think if you want to maintain the control valves at 50% opening, so in that cases your positioner will try to help you out. Trim, the trim is including with two of the main segment of the control valves, which is the stem and the plug, and which we already discussed about it. So mainly from this particular slide, the discussion or the terminology which we are able to understand is the control valve is mostly divided into the two parts, actuator and the valve will be divided into the two segments, which is body and the trim, and the actuator part will be nothing but the consisting with the positioner and the actuator. Classification of the control valve, if we talk about the classification of the control valve, will be nothing but according to the type of action, according to that number of plugs, according to the motion of the stem, according to the type of characteristics, and according to the type of uses. Already we have talked about the according to the type of action, which is here to open and here to close. We have completed this discussion. According to the number of plugs, that means we know that we are observed from the diagram that there will be a plug at the bottom end of the control valves configuration, but it is not only the single plug. We are able to go through the double configuration of the plug also, in which two plugs will be used into the control valves. According to the motion of the stem, so not only the motion will be linearly going up and down, the motion can be rotational also. So that's why the linear types of motion and the rotary types of motion is also there, which will be discussed later on. According to the type of characteristics, so it is a very important point of the discussion, which is the quick opening, linear and equal percentage. So different control valves will give the characteristics of a different types. Someone makes opening quickly, someone making the output linearly with the opening of the valves, and someone will go through in a different way, which is known as equal percentage, which will be discussed later on. According to the type of uses, that in which segment of your plant what type of control valves we need to use. So for the flow control valves, what are the valves we need to be used? We can go for the port valves, gate valves, globe valves, needle valves and the butterfly valves. If you want to go for the pressure control valves, that will be the relief valves, safety valves, and the direction control valves will be the check valves. So we will discuss these particular things later on, but these are the classification of the control valves. And already we have discussed these particular things, here to open and here to close, according to the type of action. And if we proceed to the next one, it is a very important point. Number of plugs. As I already mentioned to you, the number of plugs can be 1, the number of plugs can be 2 also. So for the number of plugs in a single seated control valves, here you are able to observe, this is a very known diagram to us right now, in which a single plug will be used. There are some advantages and disadvantages also for the single seated control valves. So only one plug with one seating surface is present in the control valve, so it is a single seated valve. So only a one plug will be attached with this control valves. The advantage of this type of valves is that it can fully close and flow variation from 0 to 100%. So that means whenever some of the fluid will go or come from the pipeline and it will try to give the force from the upward direction of your plug, so obviously the entire control valve, when it is, if it is can be considered as a ear to open control valve, so a advantageous force can be given from your liquid. So that's why it is written that the advantage of this type of valve is that it can fully close from the variation of 0 to 100%. But looking at its construction, due to the pressure drop across the orifice, a large upward force, as I already mentioned to you, a large upward force is present in the orifice area, and as a result the flow force required to move the valve against this upward thrust is also large. So because you have an additional force is given by this particular upstream liquid or upstream fluid, so whenever you want to make your control valve open, in that time an extra force you need to be provided to make it open, and thus this type of valves is more suitable for the small flow rate. If you have a very high flow rate, there will be a high pressure given into the plug at the top of your plug, so in that particular case there will be much more force will be required to open it. But for the case of a double seated valves, if we talk about, here you are able to see there will be a two plugs, so plug 1 and plug 2, and there are two plugs in a double seated valves. Flow moves upward in the orifice area and downward in the other orifice. So here also you observe there will be a two orifice area. This is the orifice area 1 and this is the orifice area 2, and the resultant upward and the downward thrust is almost same. For the last case, the upward direction force will be given by the liquid, but here what will be the case, when the liquid will come into the control valve, it will deviate it in both the directions, upward and downward. So whenever the force will be given upward and downward, that means the total resultant force will be 0, and easily your control valves can open in the pressure which you have given 3 to 15 psi. The movement of the stem can be easily handled from the upward and downward direction. But the double seated valve suffers from some of the disadvantages. What are the disadvantages? The flow cannot be shut off completely. Basically, you are not giving any type of pressure from the upward direction. So obviously, because you are nullifying the pressure, so upstream and downstream pressure will be nullified. So the flow cannot be shut off completely. Because of the differential temperature expansion of the stem and the valve sheet, if one plug is tightly closed, there is usually a small gap between the other plug and its sheet. Thus, the single-seated valves are recommended for when the valves required to be shut off completely. But there are many processes where the valve used is not expected to operate near the shut-off position. For this condition, double-seated valves are very useful. So these are the two types of valves as per the number of plugs in it. Another very important discussion about the motion of the stem. The stem motion, not, as I already mentioned to you, not only the upward and downward direction, it can be rotary also. So the motion of the stem is mostly the sliding stem valves. If we talk about the sliding stem valves can be direct acting type or reverse acting type. Direct acting type means your stem will go down when the control valve will be closed, and it will go up when your control valve will be open. So here you are able to visualize, if your stem will go down, your control valve is totally totally closed, and when it will be go up, your stem will go up, your control valve will give the opportunity to the fluid that can pass through it. So it is known as a direct acting control valves, whereas the reverse acting means the opposite phenomenon we need to be applied. If the force will be given in the downward direction, your control valve will be closed. So basically you are able to visualize that the control valve is closed, and when you are giving some force in it at the downward direction, so in that particular time your liquid can flow through it. So the opposite phenomenon need to be advised for the reverse acting time. Both the cases of control valves are used into the industrial uses as per their recommendation. And rotary type, if we talk about the rotary type of control valve, so it is nothing but the 90-degree rotation of the control valves, and it can mostly be used for the quick opening of the control valves. The control valves movements we are able to visualize from this particular ball valve, in which the ball valve is designed as spherical ball with a passage cartway through the center rotates to allow the fluid more or less access to the passageway. When the passage is parallel, so basically when your ball valve will be parallel to the direction of the fluid motion, the valve is widely open, and when the passage is aligned to the perpendicular direction to the direction of the fluid motion, the valve is fully shut off or closed. So the movement of the 90-degree from one direction to the other direction, that will be taken care by the rotary type of valves. It is nothing but the butterfly valves. The movement of the butterfly valves is again the 90-degree of the movements, and you are able to make it fully shut off. This is the fully shut off condition right now, and it is nothing but we can say 50% opening of the valves. So we have the applicability of different types of special control valves. If we talk about, we have a gate valves for the discussion right now. The gate valves is mostly suited for the quick opening type of control valves, which we will discuss later on. And the applications areas are given: oil, gas, air, slurries, heavy fluids, heavy liquids, steam, and all the things. Advantages, if we talk about, it is a high capacity control valves. That means high capacity of fluid can be handled by this control valve. Tight shut off can be done. This is the advantageous point for the gate valve. Low cost and little resistance to the flow, so there will be less resistance. If we talk about disadvantages, it is poor control. Obviously, if you have a quick opening type of valve, the controlling will be poor in the particular segment. Cavitation, it is one of the type of problem when the control valve pressure will be, the fluid pressure will be dropped at the lesser than the atmospheric pressure, and that's why it is a very dangerous situation for a control valve and cannot be used for the throttling. That means the proportional movement cannot be done by using these gate valves. Recommended uses: full open and closed. As I already mentioned to you, proportional segment of the opening and closing cannot be done by this particular valves. Infrequent operation and minimal fluid trapping in the line. So these are the recommended using part of the gate valves. If we talk about the globe valves can be used for the linear and equal percentage characteristics of the valves. Applications areas are written over here. Advantage: efficient throttling. If you want to make the proportional output from the control valve, you can go for a globe valve. Accurate flow control can be done. Obviously, if you able to make it your control valve open 10, 20, 30 and 40, so accurate flow control can be done. Available in multiple ports, so different ports can be used for this globe valve. Disadvantages: if we talk about high pressure drop, so the pressure drop will be very high and we need to take care about this particular point. More expensive than the other valves, so it is a expensive valves as well. Recommended uses are for the throttling service, frequent operations. If we talk about the ball valve, it is a rotary type of valves we can say, and already we have discussed, it is a linear and quick opening operation can be done. High capacity of the liquid flow can be handled by this particular ball valve. Low cost, the cost of this particular valve is low. Low leakage and maintenance, tight sealing with the low torque. Disadvantages: poor throttling characteristics, prone to cavitation. And the recommended uses are the limited throttling service, high temperature fluids. If we talk about the butterfly valves mostly used for the linear and the equal percentage. Advantages for this particular valve is low cost and the maintenance, high capacity, good flow control, low pressure. Disadvantages: high torque required for the control, prone to cavitation at the lower flow, and recommended uses are the fully open and closed, frequent operation, minimal fluid trapping. So these are the diagram we are able to observe. That is the closed right now, and the control valve will not give any type of output from the upstream to the downstream side, whereas the throttling will be, this is the position in which your control valve is moving right now, nearly 45 degree of angle, in which the throttling can be done by the fluids. And open condition means it's parallel to the fluid flow, and there will be lesser restriction, and the damper parallel to the fluid flow, there will be lesser restriction for the flow of the fluid. Entire fluid can flow through it. So now we talk about three of the points which are very important, is the valve packing, valve sizing, and valve capacity. Valve packing is nothing but the idea about the control valves, which is nothing but the restriction to leakage or any type of atmospheric interference into the control valves. So the leakage is simply unacceptable in many of the industrial control, and the application where we must minimize the fugitive emission, that means there will be no unwanted escape into the control valve. So in that particular case, your entire control can be hampered, and the process substance into the surroundings environment, usually from leaks, as I mentioned, leaks and around the pump and the valve shafts. And packing is a sliding stem valve fits in a section of the valve body called the bonnet. I will just go to this particular diagram through which we are able to observe. So here you are able to observe that the bonnet is nothing but the restricted part of the control valve, in which your stem and plug will be not at all get any interaction at the atmospheric condition. The packing rings, nuts, and packing flange, they all are try to maintain the entire compactness of this particular valve, that the main part of the control valves cannot be get in touch with the atmospheric condition. If we talk about the valve sizing means, if I want to purchase a control valve, what type of control valve will be required in my area of the process, that will be recommended by the valve sizing. So when the control valves operates between fully open and fully shut, they serve much the same purpose in process system as the resistors doing in the electrical circuit. So at the initial time of the discussion, we are taking an example of an electrical circuit, that the resistance what they are performing into the electrical circuit, the control valve is performing same type of things into the process. So the output of a resistance when you are incorporating it into a circuit, that is nothing but the heat. But in most control valves, the dominant mechanism of the energy dissipation comes as a result of turbulence, which is a very big factor or problematic factor for the process, and introduced to the fluid as it travels through the constructive portions of the valve trim. And the act of choosing an appropriate, this is a very important point we need to discuss, that the act of choosing an appropriate control valve for the expected energy dissipation is called the valve sizing. So the energy dissipation diagram will be given. Red arrows show the points of a maximum fluid energy loss. So whenever you are making the portion, you are able to visualize that they are the portion of the control valve in which maximum energy loss will be there, and it is not at all acceptable into the industrial concepts. So that are the points which we need to be getting idea, that what valve sizing we need to take care when we are purchasing a control valve, and that will be defined by the valve capacity. And the valve capacity is known as CV. So basically the valve capacity is known as CV, and the CV is defined as the flow. CV is mainly, I will go through the equation in the next slide. CV is nothing but defines as the flow of a fluid of unit specific gravity. So it is depending on the specific gravity and the differential pressure in the upstream and the downstream side through a fully open valve. That means there will be a pressure difference is 0 or unity, if we say, across which a pressure drop is 1.0 psi exists. So it is a unit pressure drop in which if we talk about the specific gravity of water is 1, so in that particular case whatever the flow of the liquid from your control valves, that is nothing but the CV, which is nothing but we can say it is a resistiveness of the control valve. How much resistiveness we are getting, that will be defined by this particular CV or the valve capacity. This is the equation itself which is giving the information that the flow rate is nothing but depending on the CV, which is the valve capacity, root over differential pressure by specific gravity. And del P is the pressure drop across the wide open valves in PSI. GF is the specific gravity of the fluid at steam temperature related to the water GF1, and CV is the factor associated with the capacity of the valve and the valve coefficient. So using this particular equation, if we try to observe that if the differential pressure of a control valve is 1 psi and the water will be flowing through this pipeline, that means it is also 1, that means we can say the root over del P by GF can be nothing but the unity. So whatever the flow of the liquid in a pipeline, that can be nothing but the value of the valve capacity. And in generally, if we talk about, without going through the calculation, for a sliding stem and plug type of control valve, the valve of CV is roughly equal to the square of the pipe size, is depending on the pipe size and multiplied by 10. So if we talk if we take an example of it, that if we have a 3-inch control valve, so the control valve is 3-inch, so the 3-inch means we need to be square the value, that means it is 9, and multiplied with 10 means it is 90. So here you are able to visualize CV is 90 with units corresponding to the equation which we already discussed. This implies the capacity of the fluid open valve is 90 gallons per minute, because if you are talking about the flow rate Q is equal to CV root over del P by specific gravity. So you know that if the unit values are there as per the equation, that if the value of the CV or the valve capacity is 90, we can easily say it is 90 gallons per minute. So it is a very basic equation we have, and is the problem which we try to understand that if we have a tank and some of the liquids is flowing through the pipeline, and we try to understand what is the value of the CV for this control valve. One of the information is given to you that what should be the maximum CV rating for this valve is asked to you, and here it is written that the maximum expected flow rate for this valve is 470 gallons per minute. So that means, again, if we think about this, the maximum expected flow rate. Maximum expected flow rate means it will be calculated when del P is equal to 1, and if we talk about it is a water we have, so in that case the GF will be 1. So in that case we no need to think about, because we have given the value of Q as 450 GPM gallons per minute, that means the value of CV is nothing but equal to the same value, which is 450. So that's all for the first lecture of the control valve. We will complete the rest of the part of the control valve discussion into the next lecture. Thank you.